about the future, one of the first things that comes to mind is the robot. Like those droids in Star Wars that tirelessly fulfill our every need. But how close are we to the sci-fi dream of robots that seamlessly fit into our world? Humanoid robots that look and act like us.
Your second round, sir.
Here at Virginia Tech, roboticist Dennis Hong believes that day will come only when robots master an incredibly complex skill. Something that's very difficult for them to learn, but comes naturally to us. Walking.
Oh man! So again, nobody's controlling anything, and if you look at his head, you can see that he's looking around. So he's trying to figure out where he is in the soccer field.
He may be short, he may be skinny, but he walks! And can even kick a soccer ball.
Go!
Wouldn't it be simpler to build something with treads, like on a tractor or something?
It's a very good question. Some people say we can do things with wheels.
That's right.
But my dream is to have robots living with us in our home.
And to do that, they need to climb stairs, open doors, take out the trash, and clean up the dishes.
If you want to have these type of robots living with us in an environment designed for humans, then I say that the robot needs to be the shape of a human being.
So you're acknowledging that it's a much more difficult task
Yes.
to make a humanoid robot that walks, but you're saying the payoff will one day be worth it.
Absolutely.
Dennis hopes that in the future, humanoid robots won't just do the dishes. They'll do jobs that are risky for us to do.
Dirty, dangerous tasks.
Like cleaning up after a chemical plant leak, helping people out of harm's way, or fighting fires.
Humanoid robots are really great for those kind of things. Real useful tasks and actually save people's lives.
How do you transform metal, motors, and microchips into a machine that can walk on two legs? All right, so Dennis, this is your home robot construction kit.
Yes, this is the robot cooking show, as a matter of fact.
Cooking show?
You'll be making one of these.
Oh, wow.
This is called Darwin OP.
Darwin is a pint-sized humanoid robot that Dennis created back in 2004. A research platform he uses to find out what it takes for a robot to walk on its own 2 feet.
This is all the parts you need.
Man.
And you are going to put it together today.
Yeah, right.
Are you ready?
No, this is not Lego, let me tell you. We'll start out with the M4. To create Darwin, Dennis took his clues from nature. Number 1, he needs to see. As you walk, you use your eyes to assess your environment. Darwin sees the world through this tiny webcam.
Actually, the eyes, the big ones, are just fake. The nose is actually the camera.
Wait, so you're saying that all this is just cosmetic?
Those are not the eyes.
Oh, you're such a...
We cheated.
Number 2, he needs a sense of balance. As you shift your weight from one foot to the other, your inner ear is able to sense the change in your position and keep you from falling. Darwin gets this ability from a sensor in this circuit board.
These two small things, these are the balance sensors, so it knows its orientation and direction.
Okay. That seems to want to fit right here.
Hey, you're good at this. You've done this before?
Thousands of times. Even if Darwin can see and balance, he still can't move without muscles and joints. Number 3, your muscles are your body's engine. You can't move without them. Darwin moves with the help of actuators.
For each moving joint, we have one of these actuators. There's basically electric motor.
A motor that converts electrical energy into motion. And that gives Darwin the ability to move. All right.
Yeah, you've done. Yeah.
We have arm!
Hey.
As for his sense of touch, he gets it from these 4 little sensors on the bottom of his feet. Hours later, I'm finally finished. Tell me that's the last step.
You're almost done. Now you need to attach the arm to the rest of the body, and that's the last step. Hello, I'm Darwin.
It's adorable. I can already feel him seeking world domination and wishing his screws were done better. Even though my robot's fully loaded, he can't walk yet because he still needs a brain. And that's where roboticist Dan Lee comes in.
The first thing we're going to show you is how the robot uses its vestibular sense, which is its sense of balance.
Vestibular from the word vestibule, which is one of the things in our ears.
Exactly, inside your inner ear. And so without using its vestibular sense, what would happen if we pushed the robot?
All right.
It just will fall over and then get back up.
Wow, that's pretty cool right there.
So, go ahead. Exactly.
Wow.
So now what we've done is we've trained this robot using something called reinforcement learning. So exactly what you just did, we kept pushing the robot over and over, and it was now able to figure out that every time it fell down, it was kind of a form of punishment.
When Darwin falls, his software gets an electronic signal that basically says, this is bad. After being bullied around hundreds of times, he finally learns it's better to do this. Fall over. Oh no! So the hundreds of different reps are so that it can learn from this angle and this angle and this hard and this hard and this hard.
Exactly.
I see. Dan's even teaching his robots to learn through imitation. We will rock you. This camera detects my body's movement and sends that information to Darwin's software, which quickly translates it into a copycat movement of his own. You'd think with all of this sophisticated software, Darwin would be able to keep up with me. Look forward! Oh, so sorry! But he can't.
Just trying to make a robot walk stably is ridiculously difficult. I won't say impossible, because I don't like that word, but it's a very, very difficult challenge.